Okay. So Nabeel, if I'm saying here that in the previous class we have discussed about the corrosions and rusting. Okay. So close your notebook and let you need to tell me that what are the formula for the corrosion 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 in aluminium, iron. You need to name the formula, then copper, then silver. Okay. Write down the formulas for these salts. What is the name given to the which name the layer that is found on the aluminium metal? Speak. Don't remember. Hmm?
Ferris. Wait, no,
Hmm?
that's ferris, that's iron.
Speak a little bit louder.
Ferris.
Fe. What is it?
Iron. Ferris.
Okay. Revise it with the help of your copy, and then you need to answer me.
Al2O3.
Hmm?
Al2O3.
Okay. Al2O3. Very good. And that of iron?
Fe. Fe2O3
Dot
plus
XH2O.
XH2O.
Next,
Cop.
copper.
Cu2O3.
Cu2O3.
O4.
No. CuCO3 dot CuOH
Calcium.
whole twice. Calcium carbonate, sorry, copper carbonate or copper hydroxide. Okay. Done.
Ag plus Ag.
Name the layer. Layer's name. Only tell me the
Ag.
layer.
Ag2O.
Ag2O. No, AgS. Ag2S. Its name is black color.
Its name is black color.
No, it is silver sulfide, but it is black in color. Okay. Silver sulfide. And it is black in color. And here is copper carbonate.
Is greenish.
Yes, greenish. This one, reddish brown.
Reddish brown.
But you can write brown color. Okay. And this one,
See. Wait. What is from?
hmm? It is
Also,
white. White. It
also
is
brown.
silver color. Dull silver. Dull silver color. Okay.
Okay.
Okay. Have you noted? Revise this one. Should I move forward?
Yes.
Okay. On the basis that we have heard here, okay, then you have to note it down, okay, like right, you have to complete these following reactions. Like we have Fe2O3, okay, like you have to write the chemical reactions. What happens when potassium is going to react with water, on the basis that we have learned this one, okay, and zinc when react with water, okay, aluminium, iron, Fe when react with water, and then Na, Na2CO3 react with H2SO4, okay, and CaCO3 react with HCl, and next is NaOH react with Zn. Have to write it, note it down. NaOH react with Zn, and CS3COH react with sodium. Try to write the on the basis. You can uh, take the help of your notebook also if you are getting stuck, but you have to revise at least. Okay, Nabeel, you understood? Because this we have done, and this is in your notebook. All the reactions. Note it down fast. Let me check your syllabus that is coming in your upcoming examinations. Let me check.
The first one is KOH.
COH.
Huh?
No, first one. What is the first one? Yeah, it is KOH plus hydrogen gas. KOH plus hydrogen gas.
ZNOH.
Yeah. Done?
No.
ZNO, no. Only the potassium, sodium, calcium, and magnesium form the hydroxide. Other metals react with that one, but they don't form hydroxides. Okay, do this one, please.
ZNO
Hmm?
oxide.
Yeah, it will be ZNO plus hydrogen gas. This one,
FeO plus hydrogen gas.
Fe2, Fe3O4. You are not revising anything. You are taking chemistry lightly, Nabeel. This one,
Then, I need CaCO3. Which
check. You
one?
have to answer me this question. Check with your. Let me check whether you are writing properly or not. Take the help of your notebook. If we have done this question, try to find out these answers from your with the help of your notebook. Do it fast.
I'm writing Na2CO3. And then
H2SO4, what is going to give you? Tell me fast. What is it going to give you? What is this? This is metal carbonate react with acid. What happens when metal carbonate react with acids? Tell me. Met
Na2SO4 plus H2O.
plus H2O plus. Okay.
Na2SO4
Plus.
uh, CO2 plus H2O.
Yes. CO2 plus H2O. This one.
So, CaCl2
CaCl2 plus.
plus CO2 plus H2O.
This one.
Uh, Z, wait, ZNOH.
No. Yesterday we did this question. Do it. Check in your notebook.
This one like NaOH. We didn't
What are you saying?
we didn't yesterday NaOH plus Zn we did not write it.
It will be sodium zincate. Na2ZnO2 plus hydrogen gas.
Sodium
Zincate. Na2ZnO2 plus hydrogen gas. This one.
CH3COOH plus N. Uh,
This is an acid and this is a metal. Got it?
Na
That is CH3COONA.
CS3CONA.
Yeah. CH3COONA.
These last two I don't remember.
This is the name of its name is sodium ethanoate. Sodium ethanoate. Note it down fast in your copy. Every reaction here. And what is the condition for reacting with zinc? Zinc with water? It should be in gas. It should be also in gas. Means in a steam form. Note it down fast.
Done.
Done?
Yes.
Okay. Just give me a minute. Which board you are from, Nabil? I just remember. It is IB board, na?
Which
What is the name of the board of your school?
IGCSE? Right?
It is IB board or which one?
IGCSE.
IGCSE. Okay. So as we know that we are just going to study reaction rates. Okay. Reaction rates. Just a minute. Just a minute. So Nabil, today we shall be going to start the reaction rates. Okay, what are the rates that are responsible for the for our reactions? Okay, so rate of reaction depends on so many factors. Okay, like for example, if I'm talking about the reactions, when a reaction is going to take place, it depends on several factors. Like for example, in the previous lectures or previous classes, we have studied about that there are some factor that affect the rate of reaction. Means the reaction can be slow or fast depending on the type. For example, like I told you that metals when react with water, they produce metal oxide, metal hydroxide,
Plus what?
or metal oxide
Plus hydrogen.
plus hydrogen gas. Okay. And you notice that when potassium is going to react with water, it can react with ice and form KOH plus H2. But in case of, if I'm talking about the magnesium react with water, but water should be hot. It should be hot water to form magnesium hydroxide plus hydrogen gas. Similarly, if I'm talking about the aluminium react with water in the form of gas. It should be in the gaseous state. So there are some factors that are responsible for the rate of reaction, and these factors are temperature. Temperature can be the main. Okay, temperature plays a very important role in the rate of reaction. Second is pressure. Pressure also plays an important role in the rate of reaction. Means if change in pressure can also affect the rate of reactions, mainly in gases. Okay, mainly in
Yes.
gases. And the third one is if I'm talking that is catalyst. What is catalyst? Catalysts are the substance that uh, increases the rate of reactions. Okay, that increases that by the surface area or by lowering the activation energy. Like for example, if I'm saying that if substance A is going to form B, A is going to form B. So first of all, we require some energy to give it. Like for example, you burn a coal. You burn coal. So when you are burning the coal, you will find that you need to give some energy first, and
Can I
then
give an example of catalyst?
yeah, catalyst. Yes, Nabil.
Vanadium oxide. Vanadium.
Palladium, or and other.
Vanadium is used for production of sulfuric acid.
Yeah. Okay. So if I'm saying here that if I'm talking about the rate of reactions, rate of reactions depends on different factors. Like catalyst is an important that plays an important role. For example, if you are going to in the hydrogenation reaction, hydrogenation reaction. Like for example, if you are having C3H4 and you pass the hydrogen gas, then if you pass this hydrogen gas in the presence of palladium, platinum, or nickel, any one of them, palladium, platinum, or nickel, then it will get converted into
By
C3H,
the catalyst.
yeah, C3H8. Okay. So this you will learn in the higher classes also, but I'm just teaching you that what is the role of palladium and platinum, that they are providing the surface area for the rate of reactions. Okay,
Yeah.
means the reactions, means the reaction surface can, it provides the surface. Sometimes catalyst decreases the activation energy. For example, this is the main activation energy, that if the substance A wants to convert into B, then they have to move this channel. Okay, they have to pass this channel. Okay, but catalysts might lower the energy and they may result in changing. Like for example, there are
Catalyst speed up the energy, right?
speed up the energy, but it lowers it lowers how it's speed up by lowering the activation energy. Okay, for
Okay.
example, let's suppose in a student, they are different height students. Okay, like for example, if it is there is a competition and there is a rope here, this is the rope here, and this rope, the height of this rope is like suppose 5 foot. Okay, so not everyone is able to jump over this 5 foot rope. Okay,
Okay.
5 foot. What if the teacher make this rope to 1 foot or 2 foot? Then the more number of student can pass from A
Okay.
to B, A to B. Okay, they can pass, they can jump. So this is the same thing. That activation energy lowers. Sorry, catalyst lower the activation energy so that more number of particle can pass through A to B. Okay, like for example, enzymes. There are enzymes in our body
Lower
that
the energy so more particles can pass from A to B.
yeah, yeah, A to B. So it sometimes it lowers the kinetic energy, activation energy. Sometimes it's means it lowers the activation energy by doing by providing surface area, by providing
Okay.
lower temperature and other factors also.
Yes.
Okay, like the enzymes that are present in our stomach or in our body, they plays an important role in the digestion process. Okay, like the food you eat, it it uh, it get digested in 8 hours. 8 hours. Okay. The food that you eat this time, it will be reaches into your blood cells in 8 hours. Okay. So after the 8 hours, what is going to happen here is that you need to understand that this is done. This is the this digestion of food is done in 8 hours when we are having enzymes in our body, which is making the reaction 20,000 times faster. How much time faster?
20,000.
20,000. Just something that can happen in 8 hours is
Okay.
when it is 20,000 times faster. So if it is not 20,000 times faster, then how much time it would have taken? It would
Many
take have taken many years. Okay,
yes.
when you multiply, you will get 160. Okay, and then 000 hours. Then you divide it by 24, you will get the number of days, and then you divide by 360. 360 into 24, you will get the hours. Sorry, years. How many years would it take? So enzymes. What are enzymes? Enzymes are the biocatalysts. Bio, why? Because they are present in the body. That's why bio. And catalyst means that increases the rate of reactions. Okay.
Yes.
So catalyst plays an important role. So note it down that what are the factors that are important for the factor that can affect the rate of reactions are the concentrations of reactants in the solution of like pressure of in gas. In case of gases, pressure is
My pen's ink is over. Can I?
what are you saying?
My pen's ink is over. Can I get new pen?
Yeah. Go get it.
Yes.
Just note it down, please. Done? Noted?
No.
Note it fast.
Yes. Yes. Done.
Okay. So here, if I'm saying that the concentration, okay, noted. Now the catalyst, temperature, surface area of the solid reactant, okay, pressure of the gaseous reactant, they plays a very important role in the process of, we can say that, in the process of, or in the reactions rates, okay. So if I'm talking here, what are the other factors that can be, okay? Let's do that one. Okay. What are the other factors that are responsible? Like, for example, you have a substance, like, for example, you have a substance, uh, calcium carbonate, when react with acid HCl, okay, it will gives you CaCO3 plus, like, for example, if just a minute, let you have barium chloride when react with sodium sulfate, Na2SO4, just, it will gives you barium sulfate plus sodium chloride, okay, sodium chloride, NaCl, okay, Nabeel. Now you
Yes.
know that this is aqueous, this is solid PPT, and this one is also aqueous. So what happened here is that you need to concentrate one thing, okay? That BaCl2, barium chloride will be BaCl2, okay? If you are, like, for example, if you after some time, this reaction will get means will stop. Okay, when this reaction is moving towards from left to right. Okay, but after some time, this reaction will stop. It does not mean that completely the whole barium chloride will convert it into barium sulfate and whole sodium sulfate will get converted into this one. Okay, there might be some, but if you are able to remove any one of the reactant, like for example, if you remove this one, then the reaction will move forward. But if you add more barium sulfate to the reaction from some, means if you are adding reactant, more reactant to this one, okay, this one is reactant and this one is product. Okay, so if you are adding more product to the test tube in which the reaction is taking place, means you are adding this one, the reaction will move backward. But if you are adding this one, the reaction will move forward. So it depends on the type of concentration that you have taken. Like for example, let me explain you. Like A react with B to gives you C plus D.
Okay.
And okay, and this reaction is at equilibrium. I'm using the double arrow, or you can make it like this way that this reaction can move backward and forward both. Okay, they are different. Okay, now if I'm removing the D and C, when as C and D is formed, I removed it. Okay, are you getting this one, Nabeel?
Yes.
So if you remove C and D, if you
Okay.
remove C
Keep
and D,
the reaction will
then
keep going forward.
forward. But if you don't remove it, then
If
the
you add
reaction,
C and if you add more C and D, the reaction will move backward.
yeah, you understood this one. This is a simple, very simple concept, na?
Yes.
Okay. So let you do this one. Okay, and you have to note it down that what are the effect of concentrations. Let me, and similarly for the pressure of the gas also, if you keep on increasing the pressure, then with time, let me, here's a graph that you need to make. What do you understand by this graph? What information did you get from this graph? What information did you get from this graph? That the effect of increase on concentration or pressure. If I'm talking about effect of increased concentration or pressure.
Doesn't affect the reaction.
Okay. No, it effect of increase in concentration or pressure.
If
If you're keeping
both is going same.
increasing, yeah, it will be if it is if the concentration is means of the reactant is increased, then we will say that the reaction will move forward. Okay, otherwise it will move backward. If the product concentration is increased, then it will shift backward. Okay, so what it is showing here is that higher the concentration or pressure, okay, you see that higher the concentration, you initially take that the reaction instantly move, means but after some time it become constant. Here you see that green arrow represent the concentration or low pressure, low concentration or low pressure. Okay, and high concentration and high pressure. So if you keep on adding high concentration, high pressure, okay, the reaction will take low time to achieve more product. Total mass of or that means here the more
Okay.
product is obtained. Na? Okay, the mass means here the mass. So at time t, if you take this time t, at this time, if there is low pressure, then less mass will be obtained here. Okay, whatever the value here, it will be
Okay.
this one. But if you have
The
high
amount of
pressure,
product is the same in both reaction. The reaction rate is
yeah. What do you saying? Speak a little bit louder. What are you saying?
green is just going a bit samer, but in the end they're giving same amount
Yeah,
of.
if you have low concentration after some time, the
Yes.
reaction will be slow. Means it is taking much time, but after
Yes.
some time it will become constant. So when we are having more pressure, the reaction will be fast. Okay, got
Okay.
it? So draw this graph, please. Draw this graph.
Yes.
You done? The amount
Yes.
of product is same in both the direction or reactant only, and the reaction rate is different. Okay. So now you understood the graph.
Yes.
So effect of concentration on the rate of reaction. Okay. Got it?
Yes. 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 Got it.
Okay. So if I'm talking about the rate of forward reaction and rate of backward reaction,
Yes.
just a minute. Here we have a explanation for this one. Okay. Here's the explanation, Nabeel. That compared to the reaction with reactant at low concentration or pressure, the graph line of the same reaction is higher at the concentration. Means if you have having low
Correct.
pressure, the graph line of the higher pressure is above it. Means more mass will be produced and has a steeper gradient at the start. Means they have steep. Means at the starting the reaction will be very fast, but after some time it will be slow. Okay,
Okay.
become horizontal sooner and form same amount of product. So you have to note it down whether the reaction part means after sometimes means the reaction can be fast or slow, but the same amount of product. For example, if the reaction, if you have high concentration, so the reaction might take place in 10 minutes. If it is low concentration, the reaction may take place in 25 minutes more time, but the same amount of product will be shown. They show that the increase in the concentration or pressure increases the rate of reaction. Rate means speed. Speed. So if it is from 25, if we bring it to 10 minutes or 5 minutes, it means we have increased the speed. So indirectly, we can say that on increasing the pressure or temperature, or constant, sorry, on increasing temperature, pressure, and concentration, all the three things, we can say that the rate of reaction increases. So note it down, please, fast. Note it down. Note it down.
These pens are not working.
That is not working.
Yeah, this is also same ball pen. I hate ball pens. And
Go and bring it. Do it fast. You done this one? Done, Nabeel?
No. Yes.
Okay. So you know that what are the factors that are responsible for the rate of reactions? Okay. So let's study. Let's study that what are the factors in detail. That temperature, catalyst, pressure, and volume. They are responsible for the rate of reactions mainly. Okay, so let's study one by one the rate of reactions in detail. So here, if I'm talking about this one, so rate of reaction is simply tells us that how slow or fast a reaction can be. So if I write the proper definition, the rate of chemical reaction is the speed at which the reactant are used up. Are used up means reactants that we are using A plus B reacting to give C plus D. So these are called reactant. These are reactant. So we are saying that reactants are used up, okay, up which forms to form new product. New product. Okay, that is called. Got it? Understood?
Rate of chemical reaction is the speed at which reactants are used up or the speed at which new products are formed. Okay.
Okay. In order to measure the rate of reaction, you need to measure the change. Okay, for example, over a period of time.
We measure the time, just measure the time.
Yeah. So in order to measure the rate of reaction, you need to measure the change. Okay. Change, for example, mass, what is or volume or the color over a period of time. Okay. So note this definition up to here that the rate of reaction, the rate of chemical reaction is the speed at which the reactants are used up or the speed at which the new products are formed. Because I'm going to ask you tomorrow all those that we have done today, doing today.
This rate of reaction.
We'll do it fast.
You have to write this.
Yeah. Done?
Huh? I just started.
Done up to here?
I just started.
A bit fast.
Done.
Okay. So here, if I'm talking, is that the rate of reaction? Okay. Now, if I'm talking that, for example, you add magnesium and to react with HCl, you will find that MgCl2 will be formed plus hydrogen gas. The rate of production of hydrogen gas will be faster. Okay, initially, got it? Will be faster initially, but after some time it will become slower. Got it?
Yes.
Okay. So with time, you will find that no more hydrogen gas will be produced, but initially it will be very fast. So here it will be fast at the starting point, but it will be slowing down, and then after some time the reaction will get finished and no more product will be formed. Got it? So this is
Yes.
called such result, or we can say the result of such experiment can be used or plot by this graph. We can see this graph with time, amount of product, and the time. It will be fast, then slow, and then finish. Got it? Got it? Got it?
No.
Just draw the graph only. Just draw the
I
graph.
do. I do.
You didn't understood?
Yes.
You didn't get this one, or should I explain you one more time?
This one, yes.
Okay. So just a graph amount with the amount versus time, amount of product versus time. Do this one. Make the graph only. Don't write it. I'm not asked you to write all these. Otherwise, I could have, but I'm not, because you can do this by your. Done.
Yes.
Okay. Now, changing the rate of reactions. They are the different factors that are responsible. What is the main reason that how can you change the rate of reaction? Actually, when there is a colloidal energy that is being required to make the product. Like for example, A type of substance particles are there and they are reacting with B types of particle. Okay, Br type of particles. So when they collide at faster rate, as they are colliding, okay, first A will get separated, B and B will get separated, and then
Okay.
A and B are going to make A and B are going to make bonds. Okay, A and B are going to make bonds. So this depends on the collagen energy, that how they are colliding. So when a chemical reactions occurs, the reacting particles need to meet up with each other, okay, with each in order to make new bonds. Means A substance and B substance particle must meet together. They must collide together to make new bonds. So they need enough energy to react. So they require enough energy. That is called, this energy is called activation energy when they collide. Okay, when they collide. So what is
Activate.
that? What this type of energy is required? The minimum amount of energy that is being required to convert or to react some substance, that is called activation energy. Okay,
Activation.
that is the
Okay.
minimum.
The
These
minimum
idea, huh?
required for to join in order to form new bonds is called
Yeah,
activation energy.
yeah, the minimum energy that is being required to collide the substance, different substance to form new bonds or new substance is called activation energy. These idea together are called collagen theory, and they can be used and explain. We make reactions to go more slowly or quickly. On depending on the type of activation energy, if it is high activation energy is being required, large amount of activation energy is required, the reaction will be slow. If it is lower amount of activation energy will require, then it will be fast. Okay. So these are the factors that are responsible. First is temperature. On increasing the temperature, generally the colloidal energy increases or activation energy decreases. Okay.
Okay.
Got it. So,
Yes.
and we can say that activation energy can be easily achieved when we are colliding the particles. When we increase the temperature, the particles kinetic energy will increase, and if the particles
Yes.
kinetic energy will increase, then
They will collide.
okay. So note the definition for the collagen theory. That what is collagen theory and what is activation energy. Okay, so you have to root up to here from here. Note it down. Done?
No. Yes.
So you have to note it down that the temperature on increasing the temperature, okay, the rate of reaction increases. Rate of reaction increases. So note it like this way.
On increasing temp.
Temperature, rate of reaction increases. And reason that I'm going to share these notes with you. Okay, so you have to write the reasons that when temperature increases, the particles increase, the particles kinetic energy will increase, and more number of particles will collide. When more number of particles will collide, then more easily the reaction will be, or the rate of reaction will be faster. Okay, like
Yes.
initially 5 particles were colliding per seconds. Now, if you increase the kinetic energy by heating, now it is 10 particles colliding. So the reaction rate will faster, it will get double.
Yes.
Understood? So you have to do like this way. Got it?
Yes, got it.
Next, next is size of solid particles. If the particle size, like for example here, if the surface area is increased, like if you cut, this is an iron nail, okay? And this iron nail, if you cut it into pieces, so you see that this surface and this surface is the new surface. This surface and this surface is new surface is formed. So when
Yes.
you are having, when you cut the iron piece, the new surfaces will be formed. So if you are having powder form of iron, or if you are having ball of iron and you are reacting it with one, you will find that when increasing the surface area, the rate of reaction will increase. Like I
Okay.
have given you the examples of that one
So
also.
cutting the iron into pieces will
Yeah,
increase the rate
yeah,
of reaction.
yeah. The on increase. So you simple the surface area. When the surface area increases, then rate of reaction,
Increase.
reaction
Increase.
increases. Okay, like you check if
Directly
you have,
proportional to the surface.
yeah, like for example, you have zinc reacting with HCl to produce zinc chloride plus hydrogen gas. Okay, so if you are having more hydrogen gas, if you want to produce more